Alright guys, so let's go over the vocabulary for electromagnetism. This first word is super important, and it's what this whole unit is about. Faraday's law. The law, let's talk about the non-scientific explanation, then I'll read the scientific explanation. So the non-scientific explanation means pretty much if you have a magnet and you have some coils, like copper coils, you can create a current, right? So if you have a magnet and coils, you can actually create a current. Just like if you have something with electricity flowing through it, it creates a magnetic field, it works the other way. So the actual law is stated as follows. The induced voltage in a coil is proportional to the product of the number of loops and the rate at which the magnetic field changes within those loops. So let's look at a video. Here's the law. I'm just going to put it up. This is just straight up, the definition right here. This is what it should read as. So pause that, write it down, and then I'm going to show you guys a video, and I'll go over the next one in just a second. So let's look at this video. I'm just going to mute it because it doesn't play real good because the microphone's hooked up, but the computer just doesn't play the sound real good. So let's speed it up. So essentially this guy has a ammeter here, and he has 3 coils. He has 1 copper coil. Notice that it's 1 loop. He has 10, and then he has 100, I believe, right here. And what he's going to do is he's going to get a bar magnet, and he's going to put it through the loop. There's a bar magnet. Look at this guy. And notice when he puts it through, watch this meter here. When it's just 1 coil, it doesn't move very much, but if you look real close, it'll move, right? So he's about to put it in. There he is. Watch it. You see it kind of ticks a little bit, right? And remember, our definition is, let's pause this for a second, and we're going to go back over our definition. Our definition was the induced voltage. Induced means like created. The created induced voltage in a coil is proportional to the number of loops. Well, right there, he only has 1 loop, so it's obviously not going to make a lot. And it's also proportional to the rate at which the magnetic field changes. In other words, how fast is he moving that magnet? That's the rate of change, right? If he's moving it slow, it's probably not going to create a whole lot of voltage. But if he's moving it fast, it will. So 2 things that create voltage when you have a magnet moving through a coil. Speed of which it moves through and the number of loops. So let's go back to this guy's video. This is like an Inception deal right now. We're making a video while watching a video about a video. Alright, so now he's going to the 10 coil. Notice he's hooking it up to the 10 coil. Now, same magnet. He's going to put it through and watch how it moves. See how it moves quite a bit differently? Also, I want you to notice when he's putting it in through the coil, it moves to the right, and when he's taking the magnet out, it moves to the left. So that's kind of important too. So, he's talking blah blah blah. Come on, dude. Let's get to the 100. It does make a bit more because you don't have to look close now. You can see that dial kind of flinch a little bit more. So, let's move it on to, all right, buddy. We're going to the 100 coil. We're going to the Big Daddy. Now, he gets his magnet. Now, watch how much it moves this time. It's quite a bit, right? And notice he's moving it pretty slow. So, see when he moves it fast, that knob twitches really, really fast, right? So, again, let me pause this. Actually, I'll play it, and I'm going to read it one more time. So, this is the definition. The induced voltage in a coil is proportional to the number of loops, how many loops it is that he put, and the rate at which the magnetic field changes, right? So the induced coil is proportional to the loops and the rate at which the magnetic field changes. And there you go. Those are the 2 things that are affecting the induced voltage, right? So let's go back to our deal here. There we go. So that's what you should get for the first one. Alright guys, so now let's talk about the last definition, because you only have 2, which is the transformer. Transformers are actually super interesting and kind of mind-blowing because it transforms voltage in a line up really high or down really low to where it's usable. So let's go over that because there's a lot of stuff. So in original power manufacturing and the big kind of things you see every now and then, you'll see those big like power plant areas that are usually chain linked off. Voltage starts at around 7,200 to 24,000 volts. It's very, very high. That's not really usable to the average consumer in your house, right? And it flows through these power lines, and every now and then you'll see these things on the power lines that kind of look like little canister things, right? And every now and then you'll hear, oh, the transformer blew up and my power went out. Well, these are actually transformers that step this voltage down to where it's more usable, right? So you'll see these in your power lines. The voltage starts, as I said, 7,200 to 24,000. It'll step down a few times in these power lines, and then there'll be a final step down into your house. Your household outlets range from about 120 volts, which is most of your outlets, like a lamp outlet or something like that, up to around 240 volts, which would be like your water heater or your HVAC, which is like your air conditioner heater unit, right? Those need a little bit more voltage. So let's talk about what a transformer actually does, or actually let's talk about what it's made of. So it's sort of like it's an iron core, kind of a loop, and then it has these wire rings around it. And notice there is a little bit more wires on the left, and there's less, loops on the right. Higher voltage will come in on the more loop side. It'll induce a magnetic field, which creates a lower voltage. It comes out as a lower voltage on the right side. So that's how it's stepped down or stepped up. So notice it creates that magnetic field, and then it creates a lower voltage on the right side. So these things are everywhere. Transformers are everywhere. When you plug your phone in, and everybody has a phone just about, and they have those big bricks that you plug into the wall, those are actually little mini transformers, right? So you plug it into the wall. If you use the regular wall 120 volt outlet, your phone would go bye-bye. It would fry. No more phone, right? So what that brick does on your charger is it steps that voltage down. So you plug it into the wall, so you're not getting 120 volts to blow your phone up. You're going to step it down to about 5 volts. So that way it's usable, and your phone, likes that, right? So let's go through this one more time real quick. Starts off very, very high voltage, as we said. Gets stepped up or stepped down, depending on where it's going. These little things that look like canisters, every now and then they blow up when there's a storm. They usually step the voltage down to where it's usable in your house. Most of your outlets are 120 volt outlets. This is the average outlet. The ones in laundry room, things like that, water heater, they are 240 volt outlets because they need a little bit more power, right? This is how it works. It's like an iron ring. It's got these metal loops on it. And the higher number of loops is the high voltage side, and then it'll go to the lower number of loops, and that will step the voltage down, or vice versa. It creates a magnetic field, and it steps the voltage down. You have these little transformers that are on your phone charger and a lot of different outlets, or not outlets, but you'll see the big bricks that you have to plug into the wall that are mini transformers. So now that we've sort of went over that, it's actually super cool, right? Now that we've went over that, let's talk about the definition. So this is like the scientific definition, right? So transformer is a device that reduces or increases the voltage of an alternating current. So here's our actual definition, right? A device that increases or reduces the voltage of an alternating current. Remember, it can step it up or it can step it down. For indoor house, you want to step it down, and then sometimes it steps it back up, right? So that's what a transformer is. We already went over Faraday's law. Hopefully you guys learned a little bit, and we're going to rock and roll on the unit.